Hello, good morning, Piyush, Srishti, Deepak, Unnati, Arun.
Yes, sir.
Good morning, sir.
Yes, sir. Good morning.
Tanvi,
Okay, so shall we start?
Yes.
Okay, so today we will start our second unit, distributed algorithms. Okay, so name of the unit number 2 is distributed algorithms. Now, just in a 2 minutes, I will quickly review the unit number 1. Last unit, we have seen some of the basic concept of distributed system, definition of distributed system, then how the distributed system is, then the architectural pattern of the distributed system, architectural some basic fundamental models in architectural pattern, client server and peer-to-peer. Then in a fundamentals model, there is a interaction model and some basic model. And the main important concept that we have seen in unit number 1 is the RMI, the case study. Okay, so using Java, in Java you have to implement that program. You have that program in practical session also in a laboratory assignment number 2. So you have to implement that RMI application. You can take any uh, simple example in a practical session, and when if you have to implement the means can implement city means it should be the proper example related to our real life example. Okay, so you can take that one for a mini project. So this is overall about the unit number 1. Now in unit number 2 we will see that what are the distributed algorithms that will take part in the distributed applications. Okay, so first of all, you have the knowledge, you have studied the graph in a data structure. Similarly in the TOC also you have that study. Okay, so what you learn in a graph, so when I consider any particular network and the nodes which are distributed among the networks, so it looks like a graph. Okay, the nodes are connected to each other. Okay, you are communicating with the nodes with some message passing mechanism. You can request to some node, there is a response from that node. Okay, in peer to peer network model or in a client server network model. So whenever you see that, it is the representation of that particular network is like a graph. Okay, and you know that what are the graphical algorithms to be used. Okay, so we will distributed computing system. Okay, so the topology of the distributed system is represented by the graph where the nodes represent the processes and the link represent the communication channel. Okay, so it is look like this, so you can see this. Okay, I think the screen is visible to you. So here the nodes represent the processes and the links are nothing but the communication channel. Okay, then this is the example of the client server model, and the next one is the example of the peer to peer model. You can see how it look like. So what is the basic difference between the client server and peer to peer model? I think you understood it, and in the last unit we have seen in a detail, okay, how it works. So the client will initially the when you consider the client server model, the client are nothing but it is a dumb nodes. Okay, they may have some functionality but they may not have anything. They are just participating, or they are just participating in the execution. Everything that is every functionalities are located at the server. The client is requesting something, the server is responding to the request. So that is related to the client server application. So we have taken some examples also related to the client server model. In a peer-to-peer model, you can see that the every node in a peer-to-peer model can act as a client and can act as a server also. These nodes are the individual nodes. They have their own functionalities. Every node is sufficient enough to do the execution related to particular action or what activity that assigned to that particular node, and they may can communicate with each other with related to, they may have some dependency also, but they may not have some dependency also. But in case of client server, the clients are completely depend on the server. Okay, so in a peer-to-peer network model, they may be the individual. So last time that we have seen why the distributed system is. So for example, just the realistic scenario that we have seen, the example of some particular one outlet. Okay, and similarly, if you have to open that open means if you have to extend, if you have to scale that particular business, or if you have to scale that application, you have to copy that particular model to some another node. So what does it mean? The application is same, the functionality may differ at the another node. Okay, but the main important of that application will remain the same. The objective of that application will remain the same, only you are scaling that application to some another region. Okay, because for your for your according to your need, okay, according to the need of the application, you are scaling it. Okay, so in that particular scale, every node will be considered as a unique node, or there may be the some dependability. Okay, so you can consider in a peer-to-peer model. But for the banking application, for some type of application where the client will completely depend on the server, so that application you can consider in the client server model. And some application you can consider, or according to the need or according to the way that the application execute, so you can categorize it into the peer-to-peer model. Now the next topic is related to the parallel versus distributed. Okay, so what does it mean? I think you know that the parallel computing, you know about the distributed computing, but you may have some doubts related to the parallel computing, how to differentiate, to whom that you can say that it is a parallel computing, and to whom you say it is a distributed computing. Okay, so I think all of you have you know about some example related to the parallel systems and distributed system. Okay, so for example, as a there are the many some complex problem that are executed on some high performance computing servers. Okay, so in that case, some of the task is distributed on some node. Okay, then what happened? So when you are distributing some of the complex problem among some network node, so for that, what do you say? Means what you think about it? Are they parallel or are they distributed? Okay, so are they parallelly working? So in case of a distributed also, they are parallelly working. So then how you are differentiating these two? Okay, so here there are the some of the reason that you cannot differentiate it. There is a very is the very less difference in that. So it is related to the tightly coupled or loosely coupled architecture. Okay, so which application that you can consider is in a parallel computing, and which application that you can consider in a distributed computing. So first you see this, some of the points are given here. In parallel system, the primary issues are related to the speed up, increased data handling capability. Okay, so these are the some of the issues that may related to some application. Okay, then in a distributed application, there are some issues related to the fault tolerance, synchronization, and scalability. Okay, what do you mean by the fault tolerance? If some of the node fail, means for example, if I have given some a task to some of the nodes. Okay, some database, or you can say that the nodes are important during the execution and that node fail. Okay, then what will happen next? Okay, if the request or goes to that node, then they cannot respond to that request. So in that case, the execution will not be proper, and you will not get the correct result. Okay, so that particular uh, issues can be solved by some technique. Okay, so it means that this distributed system should be fault tolerant, so that the request can be handled by some another node, some type of you can say that um, replication is possible. Some task can be replicated on some another node, some database can be replicated on some another node, and the request will not be the request will be executed. Okay, it will be transferred to some another node, and then the execution will work properly. So here the some of the differences are given. In parallel processing system, that it is a tightly coupled architecture. So you can say the interconnected hardware and the processors and some shared memory. In case of a distributed computing, you can see the every distributed system has its local memory also and some shared resources also. So that is a very less difference in that case. When I say the distributed nodes, the distributed node may have their own processor. Means every node has a is considered as a processor. It may have their own local memory. Similarly, some of the resources may be shared in that particular application. So from this diagram, you may have some idea related to this tightly coupled architecture. You know that what do you mean by the tightly coupled architecture? What do you mean by the loosely coupled architecture? Okay. So here from this diagram, you can understand it. What do you mean by the loosely coupled architecture? Okay. Then uh, here in this case, large networks are very commonplace. Means World Wide Web, that you know. Some examples of the social network, sensor network, BitTorrent, then Skype. Okay, some computational grid, some network or mobile robots. Okay, then video conferencing, live streaming, that may require some type of uh, uh, servers and the nodes to execute that. So then why the distributed system? So is all are possible in case of a parallel computing? Okay, so the issues that we have seen in the previous slide, it may have the speed up problem. The parallel computing may have a speed up problem because of the tightly coupled architecture. In case of the loosely coupled architecture, you can share some, they may have some their local memory also, and they may have some shared resources also. Okay, so this increased data handling, in case there is a issues in parallel computing, that is the data handling capability. So it may be resolved in case of a distributed application. The speed up issue can be resolved in distributed application because of what? Because they may have a separate mechanism to solve that particular type of a problem. Now, why distributed systems? Here, the some of the possible solutions are given. Okay, so some examples are given here. It has a fault tolerant system. Communication can be increased by using in an increase in a grid. Then resource sharing is possible in case of a distributed system. Okay, there may be the possible peer-to-peer network can be possible, grid can be possible. Then geographic distribution of the processes can be possible in case of a distributed system. That may not be possible in case of a parallel system. Okay, so these are the some of the services that are currently considered as an example of distributed application. That is a video distribution, then publish and subscribe service, then distance education, then net meeting. Okay, the Skype or some other another net meeting, such as that, you know, Google Meet and our Microsoft Team meeting. Okay, then web search, Google Earth, internet auctions, internet banking, everything that is that you can imagine as an example of the that are the system applications which are on internet. Okay, and that they have some type of a shared resources and some computational capability. So that application that you can consider the example of a distributed application. Okay, now though they are distributed application, they though they have some fault tolerance mechanism or speeding up or some resource sharing, but they have some issues. So you know that whenever there is a scalability, whenever there is a increase in the speed, some common database or the replication of the database. So they always there may be some problem related to that. Okay, the problems are related to these are the some of the points which are mentioned. That is the clock may not be synchronized. Okay, some address space may not be identified, topology and the routing may be that there may be several issues related to the routing of the packets and all. Then scalability, that is the main issue. Then the link may fail, that is related to the fault tolerance. Okay, so these are the some of the issues that may be possible in case of a large network, large application in distributed systems. See, so some common sub problem and then how to solve this sub problem. So these are some of the mention in case of a synchronization. So how to uh, resolve the issues of the synchronization, what type of the algorithm. So our main objective of this unit number 2 is a distributed system, distributed algorithms. So when I say that these are the parallel computing and these are the distributed computing, and how the distributed applications are, okay, what are the advantages of the distributed application as we have seen earlier. Okay, similarly, what are the issues? So now when these types of the advantages or these types of the issues are there, so then you must have to think about the algorithms also. Okay, so what are the algorithms that are used or that is now in today's distributed application or distributed system, which algorithms are working on it, okay, to solve these issues or to resolve the problem. So these are the some of the common sub problems: leader election, then mutual exclusion, time synchronization. As we have seen the issues, the same issues can be depicted here. Okay, how to manage the replica, that is related to the replica management. Then global state collection. This global state collection is a separate unit you have in a distributed consensus unit number 4. Okay, unit number 5. Okay, so you have a study of um, how to collect the state of the system, okay, at any point of time. Then the time synchronization and all that you have on unit number 3. Okay, so detail how to what are the various algorithms, okay, to for the synchronization. Okay, how to solve it, then what the some of the examples on that. Okay, but in this unit you have some description and some of the we can say that some examples related to that. Okay, so to understand that what are the algorithms are there, how to use that algorithm in various application. So these are the listing that you can see on the screen. Okay, now to understand this algorithm you have to understand the how it is, means how the models are, how means for that particular graphical problem. As we have seen, the distributed system will look like as a graph. Okay, connected nodes, the mechanism of communication in between the nodes. Okay, but for that you have to understand it, and then after that you have to use that particular algorithm for that to resolve that issue. If the issue is related to the fault tolerance, so you have to identify that how to which algorithm to be used to resolve that particular problem on that node. Okay, so you have to understand the model. Okay, so the types of processor, inter-process communication mechanism, timing, assumptions. Okay, the failure class, the security features. Okay, so these are the some of the um, examples for which you have to think of. Okay, and then accordingly you can select the algorithm. So these are the variability in the distributed system. Then you can see this uh, the hierarchical diagram, that is the real first of all the hardware part, and then the implementation of the model, and then for the models which algorithm that is to be useful. Okay, so these are the abstraction level, you can say. The models are simple abstraction. Okay, and then it hides everything actually. Okay, you will not understand, you will not able to identify that what exactly the inside part of the system. Everything is so smooth that the end user will not he is not aware of anything inside the system. Okay, so this is an abstract model of the distributed application. So this is understanding the model first of all. Now the communication of in between the that particular, how the communication is possible in that model. So here assuming that there is a graph, so you can see that this is a topology, and the graph G, that can be considered as V comma E, that is the number of vertices, the set of vertices you can say, or the set of nodes that are considered as a processes. The nodes will act as a process, and the E, that is the set of edges. These are the links that can be considered as a channels. Okay, so that can be the bidirectional or a unidirectional. Four types of the actions by process. So the internal action, input action, communication action, and output action. So these are the actions that you have to understand. What do you mean by the internal action? What is the input action? Then the communication, and then output. So here the message passing model is shown on the screen. So you can see this is a FIFO channel, where you can see that the first in first out channel. So here the message I am sent and the message I am received. So you can see this is a node. The P represent the node, and this is the message. Okay, that is transferred from the node P to node Q. So how we transfer from node to node? So you can see the path of communication in between this P and Q. So here this the green circles that you can see on the screen. These green circles are the nodes. Okay, here P and Q, you can consider the endpoints. Okay, or the two nodes P and Q, which are distributed among the network, and this red square box is a message. Okay, so the message is transferred from one node to the another node. So you can see that how it, it can be travel. So whenever it travels, so in a distributed model, you have to find out the timestamp. Means you have to first, for any message, there is a timestamp. Okay, and according to the time diagram. So when you draw the time diagram, so you can see that in a bottom of the screen there is a time diagram. So here the P is a process. The P is a process, means the P is a on node number P. Okay, the process started actually. The execution started. Similarly, on node number Q, okay, the process started. The time start. So when the time starts, so whenever the P sends a message M1, so there is a timestamp which is marked, okay, at that particular moment when the process start, and when the message received at the another end. So you can also see that when it is received. Okay, so there is a time gap in between these two, from P to Q. So when the message is travel from P to Q, so there must be some time. Okay, so for the traveling of the message from P to Q. So at that time you can mention the timestamp of the time gap in between these two, when it is received When it is received, there is maybe the time, what time the message is received and what time that message was sent. Okay, so here just for your information that how the messages travel in a network. So this is message propagation, then arbitrary but finite, in the message received. So from this diagram, you can just understand that when the message is sent and when the message is received, and how is the flow of that message in a network. Now this is the example of shared memory model, where you can see these are the four nodes which are in the network, and these are the two servers, you can say, or you can say that these are the shared memory model. Shared memory, M1 is considered as a memory and M2 is also a memory. So M1 is shared with the nodes 1, 2, 3, and the M2 is shared with the node 3 and 4. Okay, so the address space of the process overlap. Now you can see that the node number 3 is sharing with M1 also and M2 also. So the address space of the M1 and the address space of the M2 is shared with the process number 3. Okay, so what does it mean? It means that it is possible in a distributed network. Okay, so whenever there is a distributed node that may be dispersed anywhere in a network, but the address space can be shared. Okay, it doesn't have any limit. So M2 can be shared with process number 2 also. Okay, the M2 can be shared with process 1 also. So what does it mean? It means that whenever there is a need, or whenever there is a need of that particular memory, you can use that particular memory address. Only whenever, means, is according to the need of that particular application. Now you know that there is a social media application. So for a social media application, what do you think? There are the multiple users, okay, in a region. Okay, for example, if there is a 1 million user in Pune region, or you can say that in our Shivaji Nagar region. Okay, so what does it mean? It means that, so these particular users are sharing some memory addresses. Similarly, at the same time, the region which is just nearby to the our Shivaji Nagar, that users can also share the memory address space of Shivaji Nagar area. Okay, so assuming that there are the multiple servers, and there are the multiple shared resources, okay, which provides their own address space for use. So as per the need of my application, if I want to share, or I want to store something, I want to use the space for database results, so I can share that space. Similarly, someone who needs that information from that shared space, then that node can use it. Okay, so from this particular diagram, what you have to understand, you just have to understand that whatever the dispersion of the node is, whatever the distribution of the node is, the node can share the memory space. Okay, so here there is a variation of the shared memory. So last time what we have seen, these are the three nodes, 1 2 3 share the M1, and 3 4 also share M2. So 3 is the one of the node who have the both options of M1 and M2. Means the node number 3, the address of M1 and M2 shared with node number 3. It is a common. Now, so this is the another state reading model, and this is the link register model. So you can see the difference between these two models. So each process can read the state of its neighbor, and here each process can read from the write to adjacent register. The entire local state is not shared. Okay, So here what happened? So in this diagram, so what you can see in this diagram, so here each process can read the state of its neighbor. Okay, because in diagram number 1 there is only one memory. Okay, you can say that there is only one shared memory, and each process, so process number 0, 1, 2, 3, so they are communicating with only a single memory that we have not. Now here in this diagram that memory is not shown, but there is a shared memory, and that shared memory is shared with all the 4 nodes. So that's why the each process can read the state of its neighbor. Now in the second diagram, here in between 0 and 1 there is one shared memory, in between 1 and 2 there is one shared memory, in between 1 and 3 there is one shared memory model. So what does it mean? It means that whatever the the output, whatever the state of the neighbor. Now here in this case 0 and 1, so 1 and 0, they have some common memory, okay, which is in between these two. Okay, so only the adjacent node can have the shared state, not every. Now the 3, whatever the state of the node number 3, that is not available with node number 0 or node number 2 because they are not adjacent to each other. So I think all of you are getting this point. Only node number 1 is the adjacent node with all the other 3 nodes. So that's why the node number 1 only have the information of the adjacent nodes, not every node. Okay, so this particular model is more secure, you can say. But in the model number 1, where there is only one memory which is shared with all the 4, so they are sharing their state of its state of its neighbor. Now in this diagram you can see that the modeling the wireless network, communication via broadcast, limited range, dynamic topology, collision of broadcast handled by the CGSMA or CA. Then these are the protocols that you can see: the request to send, then request to receive, then okay, then request to send, then clear to receive, clear to send. Now in this diagram you can say that the nodes are dispersed 1, 2, 3, 4, 5. Then how they are connected with each other, the model wireless network. Here you can see that the node number 1, 2, 3, 0, 1, 2, 3, they are connected with one region. Node number 5, 6, 4, 5, 6 are connected in another region. And these two regions, okay, first and second half, you can see in the second diagram, they are connected with each other. That is the 3 and 5 are connected. There is a communication in link between the 3 and 5. Okay. Then synchronous versus asynchronous. Initially, you have a study of all the models. Okay. First of all, everyone has to understand what is a distributed system is. Okay, how is the communication paradigm in between these node? What is a shared memory model? If you understand this concept, then only you are able to define the proper algorithm for any problem. If there is a fault occur in between the node, you have to first understand the system, why the fault is occur, where the fault occur, where what is the shared memory or model in between these node. Okay, and then after that you can resolve this particular problem by proper solution. Otherwise you cannot handle or you cannot solve the problem which is occurred on a distributed network. First of all, you have to understand that what distributed system is. Okay, which particular shared memory model exists. Okay, how they are communicating with each other, what type of the protocol they are using. Okay, then and then only you can give the solution of that problem. Okay, you can assign the algorithm, you can find out the proper solution for that problem. Okay, similarly, in the same way, you have to understand that what do you mean by the synchrony and asynchrony of in a distributed application. So what do you mean by the synchronous clock? So you know that physical clock. Okay, so when I say physical clock, so which type of a physical clock? So my wristwatch is a physical clock, my wall clock is a physical clock. Okay, so whichever the clock, see, similarly you can say that the system clock is also a physical clock. Okay, so the physical clock are synchronized first of all. Then what do you mean by the synchronous processes? So what do you mean by the synchronous processes? So when I say that in a computer, now you know that the computer has many processes running. Okay, so one application, for example, if you have started the application of Microsoft Word, okay, similarly at the same time you are opening the browser, similarly at the same time you are opening the Microsoft PowerPoint. Okay, so now when I open the multiple applications, so the multiple processes are running in that particular application. So every process has a unique task. So now it means that there is a the timestamp associated with that process. Now whenever you go to the task manager and you say the process is running on, whenever you stop the process, whenever you start the process, so at what time, so you can understand that what the duration of that particular task you can see in the task manager. So what does it mean? It means when the process started, how much time from when the process has already started. Okay, is it halt, is it not responding, then you can kill that process or you can resume that process again, you can restart it. Okay, so that synchronization of the processes. For example, if there are some dependent event, consider the example of any transaction in a bank. Okay, you are depositing the money and then you are withdrawing the money. So what will happen if there is a no money in the bank, if there is a zero balance in my account and I am trying to withdraw? Okay, then so the withdraw is such a process. So when the withdraw process is being activated, so what does it mean? And withdraw and just a minute, 1 second, please. Hello. So, the synchronization in a distributed network, in a distributed application, is very important. In case of a distributed, if the processes are not synchronized, then there may be the possibility that the execution will not occur properly. Okay. To do the smooth execution in a processes, so the synchronization in a network, synchronization in the processes is must. Okay, so some of the examples are given in the right hand side. Send and receive can be blocking or non-blocking. These are the example of a physical clock synchronized. Then synchronous processes, you can say the example is postal communication in the. So this is the difference. First of all, this particular table is belongs to the synchronous, and this particular the right hand side column that you can say right hand side column is the outside of that particular block that you can see, that is the send and receive the block can be blocking or unblocking. Hello, so today we are concluding here only. Okay, so you can log out the session. Thank you so much.